respected Director, Center for Plant Protection Studies, respected Dean, School of Postgraduate Studies, respected university officers, heads of departments, beloved Professor and Head, Department of Agriculture and Entomology, beloved PG Coordinator, today's guest speaker, Dr. Ramesh, Principal Scientist from CACR, and my dear student friends. Good morning to all. So I am very glad to introduce Dr. K. Ramesh, who is going to deliver a guest lecture on IoT and ICT interventions in pest monitoring and management. So Dr. K. Ramesh is presently working as a Principal Scientist Agriculture and Entomology in Central Institute for Cotton Research, Regional Station, Coimbatore. So his area of research includes biorational pest management, second, insect resistant management, nanotechnology, as well as geographical information system. So he joined ICIR system in the year 2003. Initially, ICIR Regional Research Complex for NEH region Sikkim. The latter, he worked in a NBPGR, Hyderabad. And since 2016, he has been working in CACR Coimbatore. So he actually is graduated from TNAU, UG, PG, he did in TNAU. Then he did his PhD in agriculture entomology in KAU, Trichure, in the year 2006. Then to his credit, he has handled 12 institutional projects and 4 externally funded projects. Regarding publications, he has a wide range of publications. So he has 7 international papers and 41 national level papers. He has published some books as well as written chapters in books. He has attended so many conferences, seminars, symposia, etc. Regarding awards, in the morning also I was making a mention. So every year, almost once in 2 years, he is getting one or other, some or other awards. He has a very big list of awards, which include a Scientist Award, then Professor K. Kameshwar Rao Award, Fellow of the Society of Plant Protection Sciences, New Delhi, Fellow of the Plant Protection Association of New Delhi, Fellow of the Entomological Society of India, then winner WWF State Level Digital Photography, Young Scientist Award, Life Fellow of the International Consortium of Contemporary Biologists, then Young Scientist Award in one of the conferences. Then during his studies, ICIR Senior Research Fellowship, then TNAU Merit Scholarship, the National Merit Scholarship. So since 1992, he has been receiving some or other awards. So then again, he has been the member, life member of several societies, at least as per the list available here. He has been the life member, not annual member, in about 10 different societies, scientific societies. So he is a very good research worker. And also, he used to help many of our students whenever we approach him. He is a very good friend of us. We always consider him our own colleague working in ICR system. So we are very much fortunate to have Dr. Ramesh here as a guest speaker. I wholeheartedly welcome Dr. Ramesh. Similarly, I welcome all the scientists and students who are attending this seminar online and offline. Thank you.
Respected Director CPPS, respected Dean SPGS, respected university officers, heads of the departments, beloved head of the department entomology, respected senior colleagues and friends. It's a privilege. It's a great privilege to be in TNAU because it is my alma mater and it is my parent department. So it is always pleasure visiting here, and I am still a student of entomology department of here, department student here. Even last week I used your microscope with the with the kind permission from head of the department. Still I am a student learning here, so it is a great privilege to be here always. So today, so I am going to deal a topic on IoT and ICT interventions in pest monitoring and management. So I want to be a little bit interactive. Otherwise, you'll be so rigidly sitting, boring with several guest lectures. You will be, I think, a little bit bored. So I will be asking a lot of questions in between. Are you ready for that? Okay. Okay, good. So this is little unconventional topic, and quite interesting for someone, quite boring for someone. So just I will try to justify the topic with whatever possible interesting way. So little bit background is required. Actually, now we are in a different era. In last 200 years, agriculture started almost 10,000 years back. So, but in last 200 years, there are tremendous developments industrially as well as in our own agriculture fraternity. There are a lot of changes. For almost 9,800 years, we are doing subsistence farming. Just we used hand tools, we used animal power, and just we produced little produce for just for subsistence. But the industrial revolution changed everything. From for example, for last 200 years, we can see the industrial revolution can be categorized into industry 1, 2, 3, 4. Now industry revolution 4 is happening. So correspondingly, we have several things in agriculture also. We are also growing simultaneously with industrial revolutions. In fact, industrial revolution is giving much impetus to us for our developments. That can be very well categorized. Actually, before almost 18th century, we can see it is only indigenous tools. We used only animal power. But when the industrial revolution started, agriculture revolution also started. We have mass production technology came into picture. We have industrial revolution. We got electrical energy. We got mechanization. So in turn, agriculture also got benefited. So we got so much of mechanization, tractors, and several other implements, chemical fertilizers, synthesis of factory level synthesis of chemical fertilizers and pesticide. In turn, that gave green revolution to us. By several countries, we got full food self-sufficiency and revolution in several fronts. Food grains, maybe you take anything. There is a rainbow revolution in agriculture because of the industrial revolution too. Then industry 3.0 came into picture with the implementation of computers. We got information technology and automation. Correspondingly, in agriculture also, the precision agriculture got impetus with the tools available and information technology. We got GPS, we got variable rate applicators, guided system, and pest and disease monitoring through electric and electronic means. So that gave precision agriculture era in almost when I was student like you. In 1992, in fact, exactly in 1992, I joined the precision agriculture technology was kind at that time, and still we got in last 25-30 years we got much impetus in industrial research. Now we are talking about hardware software revolutions, and we got artificial intelligence, IoT, and big data, cloud computing. So many things came into picture in industry. So correspondingly, we got lot of impetus for agriculture research also. Now we are talking about robotics, we are talking about artificial intelligence, we are talking about autonomous farming. Even we got so many things. Farmers are using so much of these tools directly in. You can take almost in Tamil Nadu itself, there are a lot of AI technologies being used at even farm level. So that much penetration of AI and IoT, ICT devices entered in our field. So agriculture 4, we can talk about the core technologies which give a fillip to agriculture 4.0 are the sensors and robotic technology. Earlier sensors were very costly. Now we can get sensors became much affordable because of the advancement in fabrication and embedded systems. We are getting now very cheap sensors. We can purchase sensors starting from 100 rupees. So that made a great fillip to our IoT devices. Then again, connectivity. Earlier, 20 years back, the connectivity is very poor. Now we can see it is all interconnected. Everybody is interconnected. Every device is interconnected with our IoT technology. So we got much better connectivity now, and storage and cloud computing. Earlier, we can see our computers have 1 GB, 2 GB RAM, and 100 GB hard disk. Now it is unlimited. Even our own simple mobile got 12 GB of RAM and 1 TB of storage data. Again, we got cloud computing. So now we are getting huge account of data. So we are getting now machine learning algorithms, artificial intelligence to process these kind of data. We got facility, and again we can several decision support systems came into picture for even agriculture production, protection, improvement technology. Lot of these things are contributing for agriculture for revolution. So coming to little introduction I'll give, because I am telling about IoT, ICT. We should know what is IoT, ICT. Almost you will be nowadays you'll be every house is having IoT, ICT devices. Even in sitting here, you will be having each and everyone will be having one or two IoT devices. Can you name any one or two IoT devices you are carrying now? Phone, of course, everybody is having a mobile phone. Then laptop, good. Then smartwatch, very good. Then you have your debit card, State Bank debit card. That is having NFC chip, near field communication chip nowadays. It is even without swiping you can transact. So at least in every individual have 4 or 5 IoT devices with you are carrying all the time. If you go to your house, it is n number of devices are there. Now smart TV, smart refrigerator, smart air conditioner. Before starting your journey, you can switch off your air conditioner. You can set temperature. You can control the light in your room, in your house. You can control the color of the light just by clicking a button. RGB lights are there. I don't need white color light. I need warm white. I need blue color. So just by click a button, you can change light. Your security system, you can monitor your home. So IoT is penetrated much deeply into our lives. So that IoT we can very well use for agriculture systems also. So that is the scope we have because of the affordability, because of the availability of technology. So now we revolutionized our living, but we can do similar revolution in agriculture also. So that is all about today's topic, especially with respect to pest monitoring and management. What IoT and ICT devices we can utilize. So is it okay? Now is it you came to right mind state what is today's topic is. So this is what we are going to deal today. Yes, yeah, but there are some differences. The IoT devices we use for home automation and as well as for agriculture, because in home we have 24-hour electricity. So we are getting any amount of power we can draw, but in remote agriculture farms, power is a constraint. We can't use power hungry IoT devices because all IoT devices, your Wi-Fi, you take anything, all power hungry. It draws a lot of power. But in remote farm, you can't use power hungry devices. That is the first limitation we are facing. Second is cost. So now in cities, you can afford smart TVs for 2-3 lakh rupees. Just starting price, we are getting smart TVs, smart refrigerator, AC, all available. But farmer cannot afford this lakh kind of lakh and thousands. So we have to think about hundreds. Sensors, we have to start with a limited amount of money, limited amount of, again, connectivity is poor at the village levels. So just for agriculture, we have to rethink all these things. So we have to select accordingly the hardware devices. So what these smart and this computer hardware, software, everything to be different from what we think about IoT and ICT. For agriculture, we have to think radically different. So by starting from the hardware platforms, now we have Arduino, we have Raspberry Pi. So these are all single board computers, very affordable open source computers. So these are the whatever a computer does that same. We have RAM, we have processing unit, we have a Bluetooth connectivity, we are having Wi-Fi connectivity in the single board that I am showing you Raspberry Pi and Arduino. So it is all integrated. So, but much affordable also, just with few starting from 1,000 rupee. We can start getting single board computers. So we have to select for agriculture, IoT and ICT. We need to select the type of hardware. So this is very important. It should be open source also. There should not be any limitation while selecting the hardware. And again, we have different soil and plant sensors. Several sensors are available nowadays. Motion sensor, we can for detection of movement of insect, we can use motion sensor, infrared sensor. We have temperature, humidity, pressure, altitude, latitude, everything. GPS sensors are there. We got soil moisture sensors. We have raindrop sensors, temperature and humidity. So these price starts from just 100 rupees to 2000 rupees. We are getting an array of sensors. So these can be very well integrated with our single board computer, and based on the requirement, we can build our own systems. So again, apart from these sensors, we have several imaging sensors, RGB imaging sensors, hyperspectral, multispectral, and thermal imaging sensors can be used to detect, especially in case of entomology and pathology, we need a lot of optical sensors. Imaging sensors are required. So a lot of imaging sensors, robotics. So these hardwares you should be careful in selecting based on the need, based on the kind of IoT project you are going to undertake. So these sensors can be selected. So the mantra of selecting sensor is number one. What is the number one criteria to select sensor for agriculture? Crop cost. Second, power consumption. So we have very limited power in field. Then connectivity also we have to think. So based on this, considering these factors, the industrial application and agriculture application varies in this point. So this is a very critical point. And again, communication protocols. There are several communication protocols, starting from short range communication between your NFC chip. You have a debit card. Just you have to just close proximity of 2-3 centimeters. You can do transaction nowadays. That is short field communication. We have medium level communication, long distance communication. So based on our need, we have to select the communication protocol. So like if it is a medium distance for our within field, we can go with Wi-Fi, or even Zigbee is more power efficient. Even Wi-Fi draws more power. We can go with the Zigbee communication technology for our farm level operations. Even we can go for in long distance. Uh, of course, we have connectivity, mobile connectivity throughout the nation, 2G, 3G, 4G, now even 5G is available. So according to our need, we can select. If you are price constrained, we can even go with the 2G technology. Even if you don't have any SIM connectivity, we can go with the long range radio, like radio signals. There is LoRa technologies, the long range radio technology. So this can be, this is with nil cost. Of course, there is establishment of hardware for initial period. So these are the communication technology is very important. Based on our need, we have to select the communication technology, whether it is between sensors to sensor, or from sensor to our cloud server, or from country to another country, or city to another city. So we have to select the communication protocol. So these are the some terminologies you should know before going through ICT and IoT introduction. Is it okay now? Are you clear? Something is our vague, or is it? Yep. Can you able to follow these things? You people are 2K kids here. We are very old. We are talking about so many things. You should be telling more about these things. Have you heard of Zigbee? Have you heard of LoRa? You are using a lot of mobile devices, so you should know. You should at least start hearing these things. You people are our future for AI, artificial intelligence, and machine learning. So start reading these things along with your studies. This is, of course, this is also now. You have to be in maybe in 4-5 years. It will be all there in your syllabus because TNDA is always leading. When nobody talked about nanotechnology, TNA started a department of nanotechnology, and much ahead work is going on. So no, who knows? In next year, Department of Artificial Intelligence will be there in TNAU. So you people be ready. So with respect to hardware, we have to select software also. All open source and very simple softwares are there. Now it is not so complex like your Photoshop. That requires a lot of RAM and computing power. So we have to go while like selecting hardware, we have to select software also. First, it should be open source. It should not be priced. It should be open source. It should be simple. So lot of you might be heard about that Python, Java, C, C++ and all. Now Python is much used for programming simple things. That Arduino I told about Arduino. So Python programming is there for integrating hardware and software. And again, based on our the single board computer we are selecting, we can select Raspbian operating system like your Windows operating system. We have operating system for single board computers also. So, but of course, all are open source, all without any cost. You can do this software programming. If you can't do, we can do outsource. We can outsource the programming. So IoT software also to be decided based on our selection of IoT hardware. And of course, now cloud platform is there. We can't save the data in the field. So the data has to be whatever data is recorded in the field, it has to be pushed to cloud computing for safety reasons also. Again, for you can save the cost. You may be having 100 sensors in your field. You cannot keep a hard disk for each sensor. So now for affordable cloud computing is there. You can push your data to your cloud. You can save, you can backup, you can analyze. You even need not analyze the data in your field. The data will come to cloud computing. Cloud computing will do all kind of analysis. So cloud platform is very important in case of that's called ICT. Then cloud applications are also there. Cloud servers process the data. IoT devices receive the data. Cloud server process the data, and client devices receive the data. Client device is like your mobile phone. You will get SMS. You will get WhatsApp message. So we can configure the cloud server. It will send the SMS to you. It will send WhatsApp message to you. It can send even email to your PC, or we can configure it very easily. We can configure so that you will be sitting here. You can know the pest disease status somewhere. I will show. We are having some devices like that. We have we are working on such kind of devices. So by sitting in your lecture hall, you can observe your research trial. Maybe in next 10 years you can do. You will be doing laboratory experiment. Your trial data will be received by your mobile phone. So that kind of time is not so far. So coming to AI, I have not purposely included in my title AI because it becomes so complex. I limited to ICT, IoT, but we are going to cover artificial intelligence also. This is so I don't want to threaten you with a lot of big definitions like what is artificial intelligence. It is simple. It's just we are mimicking, like insects are mimicking nature. This artificial intelligence mimicking human being. Just we are trying to implement the human thought and behavior in machines. That is simple definition of artificial intelligence. We are living in simply we are without explicit programming. We are making the machines to think. So that programs are there. That is artificial intelligence. So it is not a big deal of what is artificial understanding, what is AI, and by looking the buzzwords like deep learning, machine learning, neural network, natural language processing, cognitive computing, these are all buzzwords, but these are all nothing. Simple. If you understand, these are all nothing. Machine learning is nothing but it is just making the system to recognize patterns. You give any image, you give any text, that without explicit programming, it reads and analyzes the data. Earlier, you might be heard about programming. We will write program if, but, lot of classes. If yes, go to this command. If no, go to that command. If it is in between, computer will stuck. Now that machine learning is not like that. Because of the development in hardware and software, it started mimicking our own thinking pattern. So we are training the machines to think by themselves. So the earlier program will stuck somewhere if it is an unknown case occurs. But the machine learning makes it responds. Even if unknown data occurs, the machine learning responds. So that kind of implementation is machine learning. Neural network, that is imitating our neurons of the brain. We have a lot of semiconductor now, 1 nanometer, 2 nanometer chips have come. Just they mimic the transistors, mimic our neuron setup. So interconnected transistors are doing the work of our neurons. So neural networks can be configured, and the natural language processing, like our I am speaking English. Some of you may from Tamil Nadu, some of you may from Kerala, Andhra. Your brain will naturally think in your mother tongue. So just like that, we are training the computer. I am now speaking now real time. Translators have come. I am speaking in English, so audience can listen my speech in Latin in real time. There is no translator. It automatically translates it in Chinese, Mandarin language, any language. That simple. Now, India almost we have more than 13, 14 official languages. I am sending one message to one Hindi farmer located at Haryana. So in real time, that message can be translated and it can reach in different language. In Assami, it can be translated in real time. It will be delivered to someone in Punjab. It will be some Kerala farmer can receive the immediate message in real time in his own Malayalam language. So then in real time, that natural language processing can be done. Earlier, it was not possible. Now it is possible. Even your mobile is equipped with the natural language processing. Again, robotics, mechanical picker, so many other things. Mechanical robotics are being implemented. Computer vision, that is based on our imaging sensors. We can do a lot of work starting from identification of RS for plant protection scientists. It is detection of disease, pest, and for an horticulture scientist, it may be harvesting a tomato. Harvesting, just you can computer vision, and you can just program it. If when it ripens to 60%, a machine picker will come and pick. So computer vision. So simply artificial intelligence is nothing but we are replacing our own sensory organs with machines. So simple, we can tell computer vision is nothing but we are extending our vision to a machine. We are robotics is nothing but we are extending our arms and we are touch feeling. We can extending to robotics. So taste, sensor again, smell, olfactory sensors, hearing. So this we are just mimicking our sensory organisms with the available hardware and software. So this is artificial intelligence. Now is it okay? Now can you get the gist of what is artificial intelligence and what can be done? So simply we are trying to mimic the machines as insects are mimicking the nature. Now we are mimicking our own qualities with the machines. So that is simple, very simple definition of artificial intelligence. Next, please. Yeah. So now we will come to the second part, application of IoT, ICT, and AI in our pest monitoring and management. So we can use the tools. Now you got the taste of what is artificial intelligence, what is ICT, what is IoT. You got a fair idea, isn't it? You got some idea. So now you can think by yourself. You have several research programs, MSc students and PhD students. You are doing several field work, laboratory work. You can start thinking. So what kind of these sensors I can use for my study? What kind of software I can develop? What kind of automation I can do in my research? So you can start thinking. A lot of work is being undertaken in these fields. We can do early detection of pest and diseases, even remote monitoring and real-time monitoring of pest and diseases. We can go for smart control of smart spraying, that is variable rate of spraying, or wherever it required only the spot spraying can be done based on the sensing data. So that applications are n number. You can go for any application. You can think anything. Just you should have some basic data. So you can have any number of applications. Just I am restricting to few applications wherein works are being undertaken. You can do pest forecasting. You can do pest modeling. So anything you can think of using these IoT, ICT, AI devices. So as entomologists, we are much worried about early detection. So now our pest and symptom identification is mostly it is done by experienced person. You have to be getting trained. You have to study at least 4-year UG, 2-year PG. Then only you will be an entomologist. 6 years of study you are doing. So, but it takes a lot of time, expertise, and there is some variation. Somebody may tell it is a rust, somebody may tell no, it is a nutritional deficiency. Yellowing may be due to nitrogen deficiency. You may tell no, it is acid infestation. So that there is quality variation is there, but so it is subject to individuals. It is subjective, so it takes a lot of time. It is delayed. So these are limitations with pest and disease identification by trained professionals. So we can do with our imaging computer vision system. We can nullify all these problems. So early detection, even sometimes we will detect only after the full infestation. Maybe field might have fully infested, then only we will come to know. So we now sensors are there, it can early detection. Even before pest occurs, we can detect based on the sensors available. So early detection is possible, and efficient monitoring is possible. And again, wide area. Suppose we are sitting here, we know only the field adjacent to us. We know the pest status of TNAU at the maximum. In one day, you can go to all the fields of TNAU. Suppose there is an outbreak of Falami worm in maize today. So at the maximum, you can survey in one taluk at the maximum. So what about the entire district, entire state, nation? We need lot of manpower, we need lot of money to do a wide area coverage. So these can be early detection monitoring can be very well. We can be implemented with the available sensors and facilities. So lot of work has been done. Lot of work has been done in early detection of pest and diseases. Only that we have to understand simple concepts of image processing. So that image acquisition, we have to how to acquire the image. We may be having different imaging sensors. We are having RGB. That is simple. Your mobile camera will record images in RGB. We can have much advanced sensors, multispectral, hyperspectral, thermal sensors, because our sense that in the electromagnetic spectrum, our vision is very limited. We can't perceive infrared, we can't see ultraviolet. Beyond that, we can't detect anything. But the hyperspectral imaging can detect infrared regions, wherein that early detection can be done very well at using infrared sensors. So multispectral imaging is very essential for early detection. Even go for hyperspectral imaging. Hyperspectral is still specific because sometimes leaf may be yellow. We don't know whether it is due to acid attack. It may be due to nitrogen deficiency. So multispectral will not differentiate. It will it will give 2-3 options. Maybe due to disease, maybe due to pest, maybe due to nutritional deficiency. We can still further go ahead with hyperspectral imaging. Hyperspectral will inspect the very narrow band of visible spectrum. So hyperspectral imaging devices cost 30 to 40 lakhs. Multispectrum we can get it for 4-5 lakhs. So still some sensors are very costly. RGB sensors you can get for 200-300 rupees. Your mobile camera, then thermal camera. So so we have to decide based on the need what kind of image acquisition system can be tried. Then we have to process. We have to pre-process the data so that your that IoT hardware will take the image for processing. So you have to do little bit processing, just like you are taking your selfie. Are you sharing directly to your friend? You are doing something. You are doing some touch up like cropping. You are just reducing the. Your mobile phone does everything while taking the photo nowadays. AI enabled camera, all your mobile phones are having. You can adjust the brightness. These are all previous thing. Brightness, contrast, exposure, and all can be adjusted earlier. Now it automatically detects. It adds new background. So it converts your face into a caricature, cartoon-like thing. So real time they are doing like that. Some pre-processing has to be done, some segmentation. So based on the program we are using, we have to segment the data. So we have to extract features. Suppose I am going to detect a leaf spot. So you have to tell the machine, I am interested in this part. So you kindly look there. So that is feature extra. This feature is only required for detection because you may be taking rice leaf. There may be 100 diseases, but you are interested in one disease. You can just tell this feature only I want. So because you can't work on every disease and every pest simultaneously, So starting, so your target area, you can do feature extraction, then you can go for machine learning classification. So that these are the steps in your any pest disease reduction. These are the factors to be taken care. Next, please. So there are several works have been done almost last 15 years. A lot of work has been done in early detection. So fixing a camera in your, you have a lot of traps. Can you name any 2, 3 trap names you are using or you are studying? Pheromone trap, good. Yellow sticky, then light trap. So now what to do? You will be doing, you have to go there. Every pheromone trap you installed. So you have to go to field. You have to mechanically count. Can you go to field daily? Farmers, pheromone trap, what is the frequency of data acquisition? Suppose your farmer is installing a pheromone trap. He goes once in a week. Your research scholar is installing a pheromone trap for your research work. At least you'll take data in 24 hours. You can't sit near the trap and you can't count every second, every minute, every hour. That you can't do, no. That can be done by integrating our image sensors. A lot of work has been done with integrating our imaging sensors and single board computer into camera, especially in archery ecosystem where farmers won't go frequently in archery ecosystems. The pest can be the trap can be integrated with the imaging system, and the image will be captured and it will be sent to the remote server, and you can know the pest status. You can configure the frequency of imaging. You can know in real time. You can know. So similarly, even light traps, even your mobile can be used. In several crops, people are working. For example, in oil-based system in oil seed pest. So you can just you focus your camera, it will tell, oh, this is Plutella larvae, this is something Philotrita. So it identifies on spot and it gives you the control measures also. So the farmers need not approach any. Now farmers, what they are doing? They are simply approaching pesticide shop. They are telling my insects are attacking my crop. Leaf became yellow. Leaf are shedding. This is the input the farmers are giving. They can go with the mobile camera. They can focus the damage symptom, and remedial measure will come in next screen. So directly we can configure these kind of things with real time pest monitoring with through machine learning. So is it you are thinking too futuristic? It will take, how many years do you think it will take to develop such a device? Just to give have a wild guess. Suppose I want to make a similar system in rice. How many years will it take? You make some guess, yeah. 1 year, 2 year, 1 month, 2 month, 1 week, 2 years. On research for MSc thesis. Here. Yes, exactly. So I will come to Dr. Kannan told exact point. I will come at the end of the presentation. I have the answer for that. So this we can develop. We are developing also. So do you think these works are only being undertaken in US, in European countries? We are also undertaking this work. Even your adjacent institute, we are doing work, and we have come out with some technologies also. In our cotton, pink bollworm is a major threat. Pink bollworm, after introduction of our BT cotton, since 2003, it disappeared. Suddenly, in 2014-15, it reappeared. It is a big menace in cotton now. So monitoring, actually, it is a hidden pest, cryptic pest. It enters inside the ball. We don't know the symptom. Only during harvest, we can know the symptom of pink bollworm, because after ball open, the symptoms will be, while picking the cotton only, we'll come to know this is infested with pink bollworm. So pheromone traps are very essential in monitoring the pink bollworm. So even ETL levels are configured. If consecutive for 3 days, if trap catch is more than 8, we can consider it is crossed ETL, because other pest you can, by pest counting, you can know the ETL, you can configure. to 2 acid per leaf or 10% of aphid infestation, 10% bolt damage, you can tell it is cross DTL. But it is a hidden pest. We don't know where is the pest. So for these kind of cryptic pests, we require pheromone traps to decide our course of action. In that case, we thought, I think it went to previous slide, please. So it is difficult for a cryptic pest. So now what we have developed a smart trap, wireless smart trap with imaging sensor, and that fellow will send you. We can install that is fitted with a solar panel. So what we did is a standalone system. You cannot give wire connection to that from your lab to field. Farmer may be in remote place. So we have made a standalone system with rechargeable battery, solar panel, and inbuilt mechanism for giving power. And there is a single board computer imaging sensor. Everything is integrated. So that fellow will take image every hour, and it will send you through mail. It will send you on WhatsApp message also with image. So we configured that kind of trap in cotton. So that got now I think we started working on since 2018. In 2022, we just came out with the product. This year, ICR recognized as one of the technologies. Every year now, starting from this year, ICR started. Previous slide, please. So now this is the smart trap we developed, so that this along with the you can keep each trap in one district. So at a click of the button, we can know this what is the pest status in each district, or even countrywide. We can keep this trap data, so we can know the pest status in real time. So this is what we did in cotton. This has been recognized as a technology by ICR. So this is the work of 2021-22. Next, please. So this is so again. So this fellow will send you images. So we have to enlarge the image. You have to count how many insects are there. So now machine learning is there. So that fellow we can make him to count. And why can't you send the number of insect trapped instead of receiving image? We made the fellow to count, and it will send you the insect count. So that work we are undertaking, and so we did machine learning training, and we have given machine learning algorithms. Almost we have detection accuracy. This is last year. Now we have increased the detection accuracy to more than 95%. Next slide, please. So this is the detection. Now earlier it sends images. Now it counts the insect, and now it sends the information to your mobile. So now we have installed these traps at Nagpur. Now I can know from if I open my mobile, there are 3-4 traps are installed across the country in our stations. So now I can open my mobile. I can tell half an hour before this is the trap catch in Nagpur. So in Haryana, less catch. Today in Nagpur, more catch. You have to be careful. Like that, I can monitor in real time. That is really happening now. I can access through my mobile. Next, please. So you can what is scientifically can we prove that what is the detection accuracy? What is the what statistical analysis it does, and the detection accuracy we can know how much accuracy, even with the confidence limits also it gives for detection. So we can know what kind of accuracy is there. We can even for research purpose we can do fine tuning. Next, please. So this is about our CICR work on development of AI-enabled trap, and so it has to be we are image based trap. It is fully optimized, and we optimize the AI trap also. So but much of the work has been done in plant pathology only. Because insects fly away, your pathology symptoms remain in field. Easy to do image detection. It is very difficult. Only in maximum, much of the work has been done in insect with respect to trap, because there insects are trapped or dead insects are there. With live insects, it is difficult to do the machine learning. But again, of course, we can secondary symptoms based on the infestation symptoms, we can do machine learning. Much of work has been is being undertaken, but 80% of the work is done with our disease detection symptoms. And again, there are so many algorithms can be developed. That is, again, I don't want to confuse you with so many jargons like Sigma that for image processing. There are so many artificial neural network, convolutional neural network, and support vector. There are these are nothing. You have a data, field data. You can analyze through SPSS package. You can analyze the same data through, or you can analyze the same data through Iristat package, or you can do manually. So like that, we have several algorithms are there. So whichever algorithm is giving best result, we can go with. There are several algorithms. We are actually, I am 20 years behind that. People, much work has been done. So, but with our limited knowledge, we have to learn and do implement this kind of. We have to understand first, then we have to use. We know we should know what we need, how to implement. So for us, it is really venturing into IoT. AI is a little tough job. Next, please. So I told for entomology and pathology, imaging sensors are very essential for early detection. We can, as I told, it can be done by simple RGB imaging camera. It can be done by hyperspectral imaging. We can several hidden. For example, we have stored product pest where thermal sensors can detect. Suppose you have a container, you want to know, you may be processing the container shipment for quarantine processing, there may be hidden pest. You can do thermal imaging based on the heat generated, you can count. So based on our need, there are several imaging sensors are available. So these are all successful applications of different imaging sensors. Next, please. So even in different ecosystem, we can use the sensors. We can use it in our laboratory, in vitro, in vivo. This is we can do it in our glasshouse condition, in open field. So several work has been done on detection of diseases using different kind of sensors in different working environments. Next, please. So this is simple step. How a machine learning is being undertaken. For example, in cotton, machine learning algorithms are developed for several diseases. Original image, what we see, RGB image, the first row will look like that. Then the threshold segmentation, we fix the target area. We need, so I am interested in cercospot. I am interested in leaf blight. So we need to tell the computer, hey, you look for these symptoms only. So that is called the threshold segmentation. Then again, we have to fix whether if it is rust. So 100 it is segment based on threshold. You can fix 95%, 90% threshold. So based on you can increase or decrease the detection accuracy. And the support vector machine, the computer reads like this last SVM segmentation. It is after machine learning. So similarly, you can see that side also. You can see that detection, disease detection type. First one is as you see RGB images. It can be just brightness. Exposure can be increased, decreased, pre-processing is done. Then for digital images, OCBC or color transformation is done. And again, it is being converted based on the algorithm we are using. So that ultimately this is being fed for training into machine learning. Then from that, it is being trained and we are getting the trained set. With that, we can do detection. Next, please. So that accuracy, it is good. If you start working on it, the accuracy, it is more above 90% accuracy can be achieved. Even 100% accuracy is being achieved in case of several diseases. Next, please. So that several ecosystems, field, on ground, even satellite image. We have drones. We can just fly a drone with hyperspectral imaging. Within no time, we can found what is the damage in one area, 1 hectare of land, or you can through satellite imaging, you can know in one district what is the infestation levels. So we have different ecosystems. We have different. These are the success stories with the different sensing technology, different crops, different. Algorithms have been developed for last almost 10, 15 years. Lot of work has been done. Next, please. So these are the different imaging system, UAV based, airborne, or handled machines or satellite imagery. So this much of the work has been done. in economically important crops. Next, please. So next comes delivery, smart delivery of pesticides, because whatever sensing is one part, then right delivery is another part, because precision farming is nothing but so much 10 minutes left out. I will finish. So it is placing the right input at right place at right time. So this is about smart delivery. Next, please. So as entomologists, we know less than 1% of the insecticide is applied to target organism. Otherwise, 99% is going waste, or it is reaching non-target organism, causing lot of environmental concerns. So smart delivery can be very well used by our AI algorithms. Next, please. So this drone technology is there again. Even we are finding difficult in drone. You can't fly drone anytime anywhere you like. If there is slight wind also, drastically the deposition rate will be different. So that now work is being undertaken. Smart delivery, actually variable rate application, or even spot application, or when there is a turbulence, when there is a difference in temperature, sensors will detect what is the wind speed, what is the relative humidity now. So optimal deposition can be achieved by sensing the data, and the delivery of the pesticide is altered on spot in real time based on the while spraying now. And several times we go for spraying in drone. With drone, there will be wind speed will be more. So that the kind of environment hampers the uh, drone application. So with real-time sensors, we can detect the environmental conditions, and the drone delivery, the pesticide delivery will be changed in real time according to the prevailing weather conditions. So that kind of research is being undertaken. Next, please. So precise weed management. So the machine learning, now we are blanket application. Entire field is covered with herbicide. Wherever maybe 5% of the area may be covered with herbicide, weeds, but we are covering the entire field. But now with the detection and targeted delivery, just we can detect the weeds. Only on the weed we can just spray the herbicide, so that we can save our environment, we can save the application cost. We can even 90% of the application cost can be saved by these kind of specific targeted application system. Next, please. So several commercially available things are developed in cotton for spot application. Next, please. So even we are not left behind. India is not left behind for telecommunication and all. We had a revolution for last 20 years. So now we have much well connectivity is there with broadband or whatever satellite imagery. So we are using agriculture. We are using several ICT technologies. Even farmers are getting. Even farmers are operating. Through mobile, they are doing lot of agriculture work, starting irrigation, especially irrigation scheduling and all. They started doing with the mobile devices. And the communication and other things are much wider application is there of ICT and IoT devices even in India. Next, please. Even in our CICR, Central Institute for Cotton Research, we are well connected with farmer through these ICT technologies. We are sending every week. We are sending advisories to farmer through voice messages. We have district level mapping, and we have for each district we have a crop calendar. So according to the calendar, we are every week message is being pushed through mobile. And of course, in last few years, we have sent 32 million voice messages across the country for 7 growing cotton farmers. District specific advisories are being sent directly to the mobile devices. So now we are utilizing all the other social media channels also for disseminating the message. Next, please. So where we stand in case of artificial intelligence work, if you see, China is leading globally. China is leading the work on artificial intelligence. United States, US is in second position, and surprisingly, India is in third position in doing artificial intelligence research. So next, please. So where it is being done? In agriculture universities, in ICR Institute, surprisingly, the work on artificial intelligence is being undertaken by private engineering colleges, private institutes, not in agriculture universities. We are in third position. Globally, we are in third rank for artificial intelligence work, but unfortunately, much of the work is being done by other institute, not by our agriculture fraternity. So that is the sad part of that, because of several hiccups, because it need lot of time to understand the concept, understand the requirement, how to implement. So these collaboration, research collaboration is much essential for the doing this kind of research. So the era has gone. Isolated research we cannot done. Otherwise, now you see, earlier only seed industry, pesticide industry was with the private. All other things are with our agriculture universities and ICR institutes. Slowly, seed companies came. Last 20 years, these seed companies occupied the seed industry. But now you see every research, agronomy, soil science, entomology, pathology research is being done by engineering graduates. They are you open YouTube, you search disease detection, which crop you whatever crop you're working, you search Google, you will find some listing. Nothing by our agriculture universities or agriculture institutes. So we have to wake up. So that is the purpose of my today's lecture. We have to wake up. We have to do. Globally, we are third, but we are left behind. Agriculture universities are left behind. Our institute, national public sector research system, we are much behind. We have to cope up with the. But in other countries, the collaborative research is very common. But in India, we are doing isolated research, so that is hampering this kind of developments. Engineering, if you go to any project, thematically that will be correct disease detection, but instead of cercospora, that fellow will be developing something for alternator in the name of cercospora. He will be something will be blight, he will be doing for leaf spot. 90% of the work is simply rubbish, because there is no technical know-how of in agriculture. But engineering, thematic, sensors, everything is perfect. But actual core problem, it is being not properly handled by those kind of engineering graduates. So we have come to a crossroad where we have to grab our own niche area in artificial intelligence. So you should have much good awareness. That is the purpose of my 1 hour lecture. So next, please. So there are some advantages. Why we need, what is the because it is so accurate, much cost effective. It because it is having very less impact on environmental impact. We can do much. We can reduce the labor cost. We can reduce the chemical cost. It even empower farmers without need of anybody. The farmers can decide in real time. So these are the advantages of AI. Next, please. But there are some challenges. We can because AI require huge account of data. We have to generate lot of data for machine learning. Again, initial investment is more compared to conventional method. We need huge initial investment. Skilled manpower is required. Then concentrated, focused research work is required for development of single product. So again, operation and maintenance, it requires annual operation and maintenance is itself requires a lot of cost. So this is the one limiting factor. Again, data breaching is there. Somebody may steal your data, but with your crop data, they can't do anything, of course. So, but there are chances that your sensitive data, private data can be hacked. Then again, in remote locations, the connectivity is a problem, bandwidth limitations are there. And again, it requires continuous education training, because every year there is updation of hardware, software. So it requires continuous focus on the research work. Next, please. So these are the several challenges. So we have to come forward for implementing this. Otherwise, we will be left alone. We will be left behind. Though India is third in research in artificial intelligence, our contribution is very limited. So now we have to wake up and we have to do work on IoT, ICT, and AI. So thank you very much for your patient listening, and hope I justified my 1 hour. If there are any queries, you can please ask. So, yes, sir. Yes.
Thank you, Dr. Ramesh. Now the topic is open for discussion. To start the discussion, yeah, your lecture was amazing, Dr. Ramesh. Actually, we were thinking that you were an agriculture scientist in a broader sense. And in particular, you are an agricultural entomologist. Now we find a software engineer in Dr. Ramesh. It's amazing. Your knowledge is really amazing. So all about software, hardware, artificial intelligence, robotics. Really, your topic is eye opener. Also, your lecture eye opener. We have to think a lot about in this particular field. So we are very much thankful to Dr. Ramesh for the wonderful lecture he has given. You already mentioned this unconventional seminar guest lecture. Really, is you are right. You are rightly pointed out that is unusual and very much interesting. I request my colleagues as well as my student friends to interact with Dr. Ramesh. You mentioned that this should be interactive, but there was not much interaction from the students. Maybe they may feel hungry. Now, please interact with our guest.
That sensory organs are telling hunger, hunger, hunger. So yes.
So whatever may be your crop, whatever may be your pest, whatever may be your topic, you can try to include the component of AI in your thesis research.
So no questions. Then you have to deposit all your mobile phones here itself. If you don't ask any questions, you have to leave mobile here only. So you are not authorized to use IoT device if you don't ask any question in IoT. Serious. I will ask here before going out, your mobiles will be collected, smart watches will be removed.
Our students are smart students only. I think you may be knowing things better than us. Naturally, feel free to talk to him.
Good afternoon, sir. Sir, what's the present situation of artificial intelligence in studying microbial culture, sir?
You have to think. I opened your eye. You have to see. You can think what applications can be done. So what is your thesis topic?
Evaluation of entomopathogens on radish flea beetle, sir.
Evolution of pathogens in
Radish flea beetle.
radish flea beetle. So first you have to identify radish flea beetle with AI system, then you can so you have to think what kind of sensors can be used, hyperspectral, multispectral, RGB, thermal. Now thought process should go in background. What kind of sensor, what kind of application field, lab, or even simple mobile. So you should tell now. You tell me what kind of sensor you are going to use.
I'll get some information
Okay.
in future.
So my lecture is just eye opener, just to give you little thought process. So in which way my research work can be clubbed. So good question to start with. Yes, please. Good question. Again, it depends on your work. I told short communication. Suppose you have a debit card, you carry a debit card in your pocket. I stand in 10 feet distance with some device to perceive data. Immediately, I will deduct money. Will you like that? No. So based on our sensitivity of data, there is short range, medium range, long range communication. So based on the data, we can decide what kind of sensors we need, what kind of distance. NFC chips, just 2 to 3 centimeters. Beyond that, it won't work. But your 2G signal will go to several 15 kilometers. It will go. So you have to decide what kind of work, what kind of sensing I need. Accordingly, you can decide the range of communication. So from back bench, last bench, no questions. Yes. I am not getting. Yes. Yes. Actually, a good question. In fact, so 2 years before we started working, I have presented you with only pink follow-up. But we started simultaneous detection of Helicoverpa, Spodoptera, pink follow-up in same trap. Yeah, we are doing that also. Good question indeed. So, but it is up to you what number of pests you have to collect. If you want more insect, you have to collect more data. You have to process same algorithm in a different way.
Then what kind of sensor that is using for the
I have to
state?
repeat my lecture again. Imaging sensors.
Sir, no, sir. In that, like temperature sensor, DHT22 is available. Like that time, what the name of the sensors?
A sensor, you say, you just Google you DTH22, it will give you DTH32, you put, it will give temperature relativity, it is just 100 rupees. You have a very simple project. You need, suppose, what is your topic of thesis crop?
Sir, my work is related to sensor-based reduction of stored grain insect pest, sir.
Oh, good. So you just keep different containers, one DTH22 in each
Yes, sir.
container, different container, plastic container,
Yes, sir.
glass
For
container.
acoustic sensor, I have decided for piezoelectric sensor, sir.
No, good.
But I have an idea that for measuring earthquake, it is also related to vibration.
Mm.
A seismometer sensor is there. So that I'm asking whether I can go for that type of sensor, sir.
You can go for thermal sensors for detection.
Okay.
You can go for sound, even sound sensor, because they nibbling sound very,
Yes, sir.
very
It is a
nibbling
decibel is
sound.
around
Yeah,
50 to 90.
so acoustic sensors you
Yes,
can
sir.
use, thermal sensor you can use. So RGB sensors, club you can club with stored grain. You can keep because relative humidity is directly related to infestation levels.
Yes, sir.
So temperature relative humidity is more temperature, high relative humidity, more pest, stored product pest. So you can club the sensors with your, you can go start with temperature and relative humidity.
Okay.
You will get the real time data. You will be getting your every minute you will be getting the data in your mobile. Maybe different container you can try. So that sky is the limit. This is stored product pest is easy to work with sensors because it is everything is under your control.
Yes, sir.
Good.
Okay, thank
So
you.
you are working on sensors. I am
Yes.
happy that. Okay, fine.
Later on, you can discuss with Ramesh, sir.
Okay.
You can discuss with your chairperson, Preetham, ma'am.
Yes.
Then discuss with the sir.
The Python starting they can, sir, actually doing work by us, everything is difficult. So little we can outsource, but Python is the programming language commonly used for IoT devices. So just little command you can start. What is Python? What are the basic commands are there? So that all too much. Only Python is okay, sir, for that. Yes, sir, we can do. Before training, we have to data set while deciding the data set. Even for 3, 4 insects, for single crop, a single module can be done, but it is little complex. It require compute little bit more time it will be taking, but our data set should be perfect. Otherwise, if I keep Spodoptera, that fellow will tell it is Helicoverpa. So that way, multiple pests. So we have to be little careful, little refinement and time factor is little more, but certainly it is possible, sir. There are several sensors can be used apart from imaging sensors, as I told, thermal sensor or even motion sensors. When there is a motion, that will detect. So motion sensors, infrared sensors, these kind of sensors can be used for specific application. But this is imaging. We can authenticate, and other sensors we don't know what insect is entering, but here we know we can cross reference with image. So it is easy but the sticky trap is not good for all pests and diseases. It is very application is very limited. Only with micro lepidopteran you can go for delta trap. Otherwise imaging it is little bit orchard ecosystem, some specific with the sticky liner we can use with limited pests. So we have to do different sensing method for different kind of traps. But of course, lot of work is being done, sir. 5 to 10 years, sir. But sometimes this kind of BT technology in 2003 it was implemented, and in 5, 6 years it reached 70% adoption, and in 10 years 98% adoption. Now irrigation automation almost Pollachi area lot of adoption is there. So mobile phone we have the fundamental device. So with that I think. So need is the mother of invention. So when there is a need, labor shortage, now cotton pickers, robot. Yes, that's what, sir. My only worry, my only the thing specifically I selected, because if you don't do, some startup will do. They are selling. You agriculture graduates, you go out And somebody, some engineering fellow will do startup. He will advertise. He know how to project his product in good website, nice website. He will advertise. He will put in Facebook, everywhere, YouTube, everywhere. He will be there. We will be left out. So my purpose of putting the seeds in you is be careful. Lot of startups are there. Engineering, your own colleagues studying in engineering colleges, they are doing lot. Now they are left out. They left all their work. Every engineering college is doing project on agriculture. Every 100 of irrigation projects, irrigation automation, so many leaf disease detection. So now you wake up. This is wake up call for you. Actually, doctor, that every month we are changing. Some long-term lure is there, but for our study purpose, every month we use season-long lure, but still we change every month. We are changing. Commercial only. We are even we tried. We purchased the synthetic. We purchased the active ingredient. We did, but if you do that, this focus will go. So somehow we have to balance. We can't do by everything by our own. We have to outsource. Synthetic lure that is working well. Field, yes, we can. Field it is difficult, but accordingly we have sensors. Thermal sensors are there. We can do, but it is a little bit costly as of now. But for they are doing for in US, and there are so many papers are there. Even flying insects, they know they have the sensors to count the number of flying insects. Of course, we have not come to that level, but it is possible. Work has been done already. Yeah, it can identify. It can identify in solar trap. If you see in light trap, you will get 100. You will get lot of insects. 90% non-target, but it will eliminate the in light trap in paddy. They have developed in China. They developed a system. It eliminates all the non-target insects. Only it counts the target insects. That